From the void of space, our planet appears as a fragile blue marble, suspended in darkness. A world of breathtaking beauty, where life thrives against all odds. But how did Earth become this cosmic oasis? And are there others like it? Chapter 1. Earth, a cosmic miracle. 4.5 billion years ago, Earth was a hellish wasteland, bombarded by asteroids, engulfed in lava. Then, a cataclysmic collision with a Mars-sized body gave us our moon, stabilizing Earth's rotation and setting the stage for life. The ingredients for life: water from the stars, comets delivered ice, filling ancient oceans. The first sparks, deep-sea vents, may have incubated the first life. The Great Oxidation Event, cyanobacteria pumped oxygen into the air, transforming the planet. Over eons, Earth became a living engine, tectonic plates recycling nutrients, the magnetic field shielding life from solar storms, and the atmosphere balancing just enough warmth to sustain us. Deeper dive: the precise balance that makes Earth unique. Venus is a scorching wasteland. Mars is a frozen desert. So why did Earth become the Goldilocks planet? Critical factors. 1. The right distance: Earth orbits in the Sun's habitable zone. 2. The Moon's influence stabilizes Earth's tilt, preventing extreme climate swings. 3. The carbon cycle: volcanoes and oceans regulate CO2, keeping temperatures stable. 4. The magnetic shield deflects deadly solar winds. Without these defenses, life as we know it would be impossible. Milky Way: the solar system begins. About 4.6 billion years ago, a massive cloud of gas and dust, known as a solar nebula, floated in a quiet corner of the Milky Way. Then something stirred it. Perhaps a nearby supernova exploded, sending shockwaves through the cloud. Gravity took over. The cloud collapsed inward, spinning faster and faster. At its center, a new star ignited, our Sun. Around it, leftover gas and dust began to clump together, forming countless tiny bodies: rocks, ice, metal, the building blocks of planets. These fragments collided and merged, growing into larger bodies called planetesimals. Over millions of years, planetesimals gathered mass, heat, and motion, including one that would become Earth. Fire Earth, the hell planet. The early Earth was not the blue oasis we see today. It was a molten inferno. Constantly bombarded by asteroids and meteors, its surface churned with lava and toxic gases. This period is known as the Hadean Aeon, named after the Greek underworld. The planet was unstable, chaotic, and violent. No oceans, no air to breathe, no life. New Moon: the giant impact, Moon's birth. Then came a moment that changed everything. Roughly 4.5 billion years ago, a Mars-sized protoplanet named Theia slammed into the young Earth. The impact was cataclysmic, so violent it vaporized rock and flung debris into space. This debris, caught in Earth's gravity, began to coalesce and formed our moon. But the moon was more than a cosmic byproduct. It became Earth's stabilizer. It slowed Earth's rotation, regulated its tilt, and gave rise to predictable seasons and tides, crucial conditions for life to eventually emerge. Droplet water arrives, seeds of oceans. As Earth cooled, its surface began to harden. But where did all the water come from? Scientists believe that comets and icy asteroids, rich in frozen water, bombarded Earth during a period known as the Late Heavy Bombardment. These celestial visitors delivered enough water to fill Earth's first oceans, creating vast, steaming seas under a dense, hostile sky. Volcano: the spark of life. In the depths, beneath these oceans, volcanic cracks called hydrothermal vents spewed heat and minerals into the water. Some scientists believe that these vents acted as cradles for the first life, where simple molecules, under pressure and heat, gave rise to organic compounds, and eventually, the first single-celled organisms. Chapter 2. The future of exploration: hunting for another Earth. For centuries, we could only imagine distant worlds. Now, we're on the verge of finding Earth's twin. But how? Next-gen telescopes and missions. 1. James Webb Space Telescope, JWST. analyzing exoplanet atmospheres for water, methane, and oxygen. 2. Habitable Exoplanet Observatory, HABEX, future telescope designed to directly image Earth-like planets. 3. LUVOIR, a super telescope that could spot continents and oceans on exoplanets. 4. Interstellar probes, concepts like Breakthrough Starshot aim to send nanoprobes to Alpha Centauri. The ultimate goal, a second pale blue. Within the next decade, we may find a world with oceans, oxygen, and even signs of life. But what then? The next step? Sending probes, or even one day humans. Imagine standing on the shores of an alien ocean, beneath the light of a foreign sun. Final chapter, are we alone? Earth is our only home, for now. But the universe is vast, with trillions of stars, each potentially hosting its own Earth. The search isn't just about science, it's about our place in the cosmos.